I wanted to create a small robot dog that could live on my desk. I wanted it to be inexpensive. In fact, you can build your own for less than $50. It can walk, avoid obstacles, play, and just mess around. It took me months to find the right material and a structure that's cheap, strong, and easy to repair, like swapping a servo. I'm sharing it hoping it helps you build your own. For the body, I used simple PVC sheets. They are cheap, lightweight, and very easy to cut and assemble. I started with the legs. Each leg has 2 degrees of freedom, which means 2 servo motors per leg. I cut 2 simple PVC pieces and attached them directly to the servos. The servos are mounted in a way that makes them easy to remove and replace. This is important when experimenting, because servos are often the first components to fail. This part is crucial, so grab a coffee and get comfortable. It's almost time to test the first leg movement. But first, let's see how to use the servo driver. All the servos have to be connected to the servo driver, which communicates with the ESP32 via I2C. This means the 2 wires, SDA and SCL, should be connected to GPIO21 and GPIO22 on the ESP32. Then connect VCC to 3.3 volts and GND to ground. Finally, don't forget to connect the servo power supply to VIN. Now we can upload the code and get the first movement of a leg. And even 2 legs if we connect another servo to the driver. Once the legs are working, I build the main body. This square backplate holds the electronics and connects all 4 legs together. On top of it, I mount the ESP32 and the servo driver. Finally added the neck. I cheated a little by using a 3D printed support for the ultrasonic sensor, but you can literally glue it to the servo mount. I connected the neck servo to the last channel of the servo driver. The ultrasonic sensor is directly connected to 2 GPIO pins of the ESP32. For more details, you can find an introduction to ultrasonic sensors in another video. Link in the description. To make the robot energetically autonomous, I used a power bank. It's not very elegant, but it's cheaper than buying batteries and all the circuitry needed to charge and regulate them. The moving head gives the robot personality. It can look toward nearby objects and react to its surroundings, and even with very simple logic, it already feels much more alive. I also wrote a modular control framework that I'll share, designed to make the robot easy to control and extend. In the next video, I'll dive into the code. The full code will be shared, so you can build on it and make this robot your own. If you appreciated this project, don't forget to like and subscribe.